Imagine walking through a farm where the air feels fresh, the soil beneath your feet is dark and crumbly, and the plants stand strong and healthy. Birds and insects are active, but they're not a threat. They're part of the balance. Now imagine the opposite. A field where the soil is pale and dusty. The plants are weak, pests swarm around. And year after year, the yields drop, no matter how much fertilizer you add. These two farms might exist just a few kilometers apart. But the difference between them isn't luck. It's the result of how the farmer manages the land. One of the most powerful tools in the farmer's hands is something as old as agriculture itself. The careful choice of what to plant, when to plant it, and how different crops interact with each other. This is where intercropping and crop rotation come in. For centuries, traditional farmers understood that planting the same thing in the same place every year leads to problems. Pests learn where to find their favorite meal, diseases build up in the soil, and the land slowly loses the nutrients that specific crops demand. Without intervention, the farmer becomes trapped in a cycle of increasing costs. More fertilizer, more pesticides, more labor, just to maintain the same yield. In contrast, farmers who rotate crops or plant them together in smart combinations work with nature instead of against it. By varying the plant families grown in a field over time, or by mixing compatible species side by side, they keep pests guessing, maintain soil fertility, and use sunlight, water, and nutrients more efficiently. In today's world, where climate change and soil degradation threaten food security, these methods are not just nice traditions, but essential strategies for sustainable farming. Even as high-tech agriculture develops sensors, drones, and artificial intelligence, the principles of intercropping and crop rotation remain relevant. They are techniques that can be adapted to almost any farm, whether it's a backyard garden, a small family plot, or hundreds of hectares of commercial fields. In this video, we'll explore what intercropping and crop rotation really are, the science that makes them so effective, the real-world benefits they bring, and how you can apply them step by step in your own farming practice. Whether you're a beginner looking to start a garden or an experienced farmer aiming to improve yields, what you'll learn here can help you build healthier soil, reduce your dependence on chemicals, and increase your farm's long-term productivity. This isn't just about growing more, it's about growing smarter. Before we dive into the practical steps, it's important to understand exactly what crop rotation and intercropping are, because while they share the same goal, healthier soil, stronger plants, and better yields, they work in different ways and suit different farming situations. Crop rotation is one of the oldest agricultural practices in human history. At its core, it's the deliberate sequence of planting different crops in the same field across seasons or years. The idea is simple. Instead of exhausting the soil by planting the same thing over and over, you give it a break by alternating with crops that restore what the previous crop took away. This could mean planting nitrogen-hungry maize one year, followed by nitrogen-fixing beans the next, then perhaps a root crop like carrots or potatoes after that. The practice goes back thousands of years. European farmers in the Middle Ages used a three-field system where one field grew a cereal crop, the second grew legumes, and the third was left fallow to recover. By cycling through different plant families, farmers disrupted the life cycles of pests and diseases, maintained a balance of nutrients, and allowed the soil structure to recover naturally. Intercropping, on the other hand, is about what happens within a single growing season. Instead of planting one crop across the whole field, you grow two or more crops together in the same space. This might mean alternating rows of maize and beans, planting strips of vegetables alongside herbs, or even mixing plants in the same bed so that they grow simultaneously. The magic of intercropping lies in choosing crops that complement rather than compete with each other. Some plants have deep roots that pull up nutrients from far below, while others have shallow roots that take advantage of moisture near the surface. Tall plants can provide shade for shorter, shade-loving species. Some flowers attract pollinators or beneficial insects that help protect their neighbors from pests. And legumes, once again, play a starring role by adding nitrogen to the soil. which benefits their non-legume partners. While rotation works over time and intercropping works in space, the two methods are not mutually exclusive. Many successful farmers use both. You might rotate crops season to season and also intercrop within those rotations to maximize efficiency and resilience. Both methods are grounded in the same principle: diversity. Nature thrives on variety, and the more diversity you bring to your fields, the more stable and productive your system becomes. By breaking the monotony of monoculture, you reduce the risk of widespread pest outbreaks, keep weeds in check, and maintain a healthier balance of soil microorganisms. In a world where farming is often pushed toward uniformity and scale, these time-tested techniques remind us that working with nature's complexity is often the smartest way forward. To truly understand why crop rotation and intercropping work so well, we need to take a closer look at the world beneath our feet. Soil is not just dirt. It's a living, breathing ecosystem teeming with billions of microorganisms in every handful. Bacteria, fungi, protozoa, nematodes, earthworms, and countless other tiny life forms work together in a complex web of relationships. These organisms break down organic matter, release nutrients, improve soil structure, and even protect plants from disease. When soil is managed poorly, this living network becomes disrupted, and the result is compacted, lifeless ground that struggles to support healthy crops. But when soil is treated as an ecosystem rather than a mere medium for roots, it can remain fertile for generations. One of the key players in this underground network is the group of nitrogen-fixing bacteria, often found in partnership with legumes such as beans, peas, or clover. These bacteria can take nitrogen gas from the air, something plants cannot use directly, and convert it into ammonia, a form plants can absorb, breaking up compacted layers and bringing up minerals from below. Others spread fibrous roots close to the surface, holding the soil together and preventing erosion. This diversity underground mirrors the diversity above ground, where different leaf shapes and plant heights capture sunlight at various angles, making more efficient use of the available energy. The microbial life in soil also thrives on variety. Just as humans need a balanced diet to stay healthy, soil organisms need a mix of organic materials from different plants. Continuous monoculture starves certain beneficial microbes while allowing harmful pathogens to dominate. But when you change crops or mix them together, you feed a broader spectrum of soil life, creating a more balanced microbial community. This balance is what helps plants resist disease naturally. Healthy soils are like a well-defended city. The benefits are not just visible, they are measurable. One of the most immediate and important advantages is improved nutrient management. Every crop has its own appetite for nutrients. By planting a rotation where heavy feeders follow nitrogen fixers, you naturally replenish what the previous crop removed. This balanced nutrient cycling means the soil doesn't get depleted as quickly, reducing the need for costly synthetic fertilizers and helping maintain fertility over the long term. When you grow the same crop in the same place year after year, you're essentially laying out a welcome mat for them, season after season. But if you change what's planted, this break in their chain of survival means you can reduce pesticide use, saving money and lowering your environmental impact. Another advantage is weed suppression. Different crops compete with weeds in different ways. Some, like dense-growing grains, shade the ground and prevent light from reaching weed seeds, while others release natural chemicals that inhibit weed germination. By rotating crops with varying growth patterns and canopy structures, you make it harder for a single weed species to dominate the field. Over time, crop rotation also improves the soil's physical structure. Deep-rooted crops can break up compacted soil layers, more porous and better at retaining both water and nutrients. This means crops are more resilient during droughts and heavy rains, as the soil can handle extremes more effectively. By rotating crops, you reduce the risk of catastrophic loss because you're not relying on a single crop for your income or food supply. Even if one crop underperforms, Others in the rotation can compensate, providing a more consistent harvest year after year. In essence, crop rotation is a long-term investment in your farm's productivity. It's a strategy that works quietly in the background, season after season, building a stronger foundation for future growth. It requires planning and discipline, but the rewards, a richer soil, healthier plants, fewer pests, and steadier yields, make it one of the smartest moves any farmer can make. If crop rotation is about working with time, intercropping is about working with space. The idea of growing different crops together in the same field may seem simple, but the benefits go far beyond just saving space. One of the most obvious advantages is the efficient use of land. In a monoculture system, each plant species occupies the same layer of sunlight, water, and nutrients, often leaving unused resources in other layers of the environment. With intercropping, tall crops like maize can capture sunlight high above, while shorter crops like beans or leafy greens thrive in the partial shade below. This vertical layering allows you to harvest more total biomass and more total food from the same plot of land. Intercropping also creates a kind of natural pest management system. Certain plants act as repellents or trap crops that lure pests away from the main crop. For example, marigolds release compounds that repel nematodes, and planting them alongside vegetables can reduce pest pressure without chemical intervention. Other combinations confuse pests by breaking up the visual and chemical signals they use to locate their preferred hosts. This means that a pest might find it harder to locate an isolated row of cabbage hidden among rows of onions and herbs. There's also the benefit of microclimate management. In many regions, crops suffer from heat stress, wind damage, or excessive evaporation from the soil surface. By mixing crops with different shapes and canopy heights, intercropping can create a more favorable environment for all plants involved. Taller plants provide shade, reducing soil temperatures and conserving moisture, while ground cover crops reduce wind speed at the soil surface and protect young seedlings from harsh conditions. Nutrient sharing is another key advantage. Leguminous crops, with their nitrogen-fixing abilities, can feed their neighbors during the growing season. Deep-rooted plants can bring up minerals from lower soil layers, making them available to shallow-rooted companions when those minerals are returned to the surface as organic matter. Over time, this sharing builds a more balanced nutrient profile in the soil without the need for heavy fertilizer inputs. Risk reduction is yet another strength of intercropping. Farming always carries uncertainties. Weather changes, disease outbreaks, or market fluctuations can wipe out a single crop. By growing multiple crops together, you spread that risk. If one fails due to pests, drought, or disease, the others may still thrive, ensuring that you still have something to harvest and sell. This diversity not only protects the farmer's income, but also strengthens food security at the community level. Perhaps the most underrated benefit of intercropping is the biodiversity it encourages. More plant species mean more habitats and food sources for beneficial insects, birds, and soil organisms. This increase in biodiversity helps create a self-regulating system where natural predators keep pests under control and pollinators are abundant. Over time, this living web becomes a form of resilience, making the entire farm more stable and less dependent on outside inputs. In short, intercropping transforms a field into a dynamic, multi-layered ecosystem where every plant has a role to play. Instead of fighting against nature to control pests, manage nutrients, or conserve water, the farmer designs a community of plants that support each other. This not only makes better use of every square meter, but also builds a stronger, healthier farm that can withstand the challenges of a changing world. Knowing the theory behind crop rotation and intercropping is one thing. Putting them into practice on your own land is another. The key to success is planning, because these methods are most effective when they're thought out ahead of the planting season and adjusted over time as you observe the results. Let's start with crop rotation. The first step is understanding your soil. This means doing a soil test, which tells you the levels of major nutrients, the pH, and sometimes the organic matter content. With this knowledge, you can identify which crops will thrive and which will help restore balance. Once you know your soil's condition, map your fields or garden beds. Divide them into sections based on size, accessibility, and sunlight exposure. Next, group crops by their plant family, because pests and diseases often target specific families. For example, tomatoes, peppers, and eggplants all belong to the nightshade family, helping you avoid accidental repetition. For intercropping, the approach is a little different because you're designing plant combinations for the same season and the same space. Begin by choosing crops that are compatible in terms of growth habit, nutrient needs, and harvest timing. Pair deep-rooted plants with shallow-rooted ones, tall crops with shorter shade-tolerant ones, and heavy feeders with nitrogen fixers. Pay attention to spacing. If plants are too close, they will compete instead of complementing each other. In row intercropping, for example, alternating 2 rows of maize with 2 rows of beans can work well, while in strip intercropping you might have wider bands of different crops to allow for easier mechanization. Timing is another factor. Relay intercropping, where a second crop is sown before the first is harvested, can extend productivity without leaving soil bare. For example, you could plant fast-growing lettuce between slower-growing tomatoes, harvesting the lettuce before the tomato plants need the space. Incorporating flowers and herbs into your intercropping system can also boost pollination and attract beneficial insects, while adding an extra product to sell or use. Whether you are rotating crops over years or mixing them within a season, observation is your most valuable tool. Walk your fields regularly, take notes on plant health, pest activity, and yield performance. Adjust your combinations and sequences based on what works best in your specific environment. Over time, you'll build a customized system that fits your climate, soil, market, and resources, delivering the maximum benefits these methods have to offer. While crop rotation and intercropping offer impressive benefits, it would be unrealistic to pretend they are without challenges. Like any farming practice, they require knowledge, planning, and adaptation to local conditions. One of the first difficulties many farmers encounter is the increased complexity of management. In a monoculture system, you can repeat the same steps year after year with minimal changes, but rotation and intercropping demand careful record-keeping and forward-thinking. You have to know not only what you're planting now, but what you planted last season and what you will plant next season. For intercropping, you must also plan planting and harvesting schedules for multiple crops in the same field, making sure one crop's growth doesn't overshadow or choke out another. This can feel overwhelming at first, especially for farmers accustomed to simpler single-crop systems. Another challenge is the gap in knowledge and training. While older generations may have traditional knowledge of these methods, younger farmers often start with little practical experience. The result is trial and error, which can be costly in time and resources. Access to reliable information, whether through agricultural extension services, farmer cooperatives, or online resources, is essential. Without guidance, it's easy to make mistakes, such as pairing crops that compete for the same nutrients or rotating crops within the same plant family, which undermines the whole system. Mechanization can also be a hurdle, particularly with intercropping. Modern agricultural machinery is often designed for uniform fields of a single crop. When you mix crops in the same space, the equipment may not work as efficiently, requiring either manual labor or modified tools. For small-scale farms, this might be manageable, but for large-scale commercial operations, it can be a significant barrier. Some farmers address this by using strip intercropping instead of mixed intercropping, allowing machinery to work within individual strips while still gaining the benefits of diversity. Market demand is another consideration. Growing a variety of crops is great for the soil, but if you can't sell them, your income suffers. A rotation plan might require you to grow certain crops that are less profitable or less popular in your region. The solution here often lies in developing new markets, selling directly to consumers, adding value through processing, or collaborating with other farmers to pool and market diverse product together. Finally, there's the challenge of patience. The most dramatic improvements in soil health and pest control don't happen overnight. In the first year or two, you might not see much change, and this can discourage some farmers into reverting to old practices. But those who persist usually find that after several seasons, the benefits start to compound. Yields become more stable, input costs drop, and the land becomes noticeably more resilient. The key to overcoming all these challenges is to start small. Experiment on a portion of your land before scaling up. Keep detailed records, learn from both successes and failures, and seek out advice from other farmers who have mastered these techniques. Remember, crop rotation and intercropping are not rigid formulas. They are flexible systems that can be adapted to your unique conditions. With persistence and a willingness to adjust, the initial challenges can be transformed into long-term strengths. One of the most powerful ways to understand the value of crop rotation and intercropping is to see how they work in the real world, on real farms with real challenges. Let's start with a small-scale farm in East Africa. For years, the farmer planted maize on the same plot season after season. At first, yields were good, but over time, the soil became depleted, pests like stem borers became harder to control, and the farm's income began to shrink. After attending a local agricultural workshop, the farmer decided to introduce a 3-year rotation: maize in the first year, beans in the second, and sweet potatoes in the third. Within 2 seasons, soil tests showed higher organic matter and nitrogen levels, and pest damage had dropped significantly. The farmer also found that diversifying crops opened new market opportunities. Beans and sweet potatoes sold well alongside maize, providing a steadier cash flow throughout the year. On the other side of the world, in the American Midwest, a large-scale grain producer faced the challenge of reducing chemical inputs without sacrificing yields. Instead of planting corn after corn, he rotated with soybeans and winter wheat, and in some fields introduced cover crops like clover and rye. The soybeans fixed nitrogen for the following corn crop, while cover crops protected the soil over winter and suppressed weeds. After several years, herbicide use dropped by 40%, fertilizer costs were reduced, and yields remained stable even in years with less rainfall. The farmer credited crop rotation for building soil structure and moisture retention, making the fields more resilient during dry spells. In Southeast Asia, an innovative intercropping project combined vegetables and herbs in the same beds to increase income for smallholder farmers. Farmers planted chili peppers alongside basil and lemongrass, crops that thrived together without competing heavily for resources. The herbs helped repel certain insect pests from the peppers, reducing pesticide use, while the peppers provided partial shade that improved herb quality during the hottest months. This combination allowed farmers to harvest and sell products at different times, smoothing out income instead of relying on a single crop season. Even in urban settings, these techniques have proven valuable. In community gardens in Europe, building a sense of connection between people and the land. These stories share a common thread. Farmers, whether working on a few hundred square meters or thousands of hectares, found that by introducing diversity into their cropping systems, they gained more than just healthier soil. They built resilience, reduced dependency on costly inputs, opened up new markets, and created farming systems that could better withstand environmental and economic challenges. In each case, the change started with a willingness to experiment and a commitment to learning from the land season after season. While the benefits of crop rotation and intercropping are clear at the farm level, their impact reaches far beyond individual plots of land. When these methods are adopted on a larger scale, they contribute to environmental health in ways that affect entire regions, watersheds, and even the global climate. One of the most significant contributions is in reducing chemical dependency. Farms that rotate crops or intercrop effectively can often cut back on synthetic fertilizers and pesticides. This means fewer chemicals leaching into groundwater, fewer residues entering rivers and lakes, and less harm to aquatic ecosystems. in places where agriculture is a major source of water pollution. Healthy soils rich in organic matter act as carbon sinks, storing carbon that would otherwise be released into the atmosphere as carbon dioxide, a key driver of climate change. Crop rotation and intercropping, by supporting diverse root systems and adding organic residues to the soil, help build that organic matter over time. Diversified farms provide food and shelter for pollinators, beneficial insects, birds, and small mammals. Intercropping in particular can turn a uniform field into a mosaic of habitats. These methods also help protect against soil erosion, which is one of the most pressing environmental challenges in agriculture. By maintaining continuous ground cover and varying root depths, rotation and intercropping keep topsoil in place during heavy rains and strong winds. This means less sediment washing into waterways, preserving both soil fertility and the health of downstream ecosystems. Perhaps the most far-reaching environmental impact comes from their role in building resilience to climate change. As weather patterns become more erratic, systems that rely on a single crop are vulnerable to total loss in a bad season. Diverse systems, however, spread that risk and are better able to cope with extremes in temperature, rainfall, and pest outbreaks. In this way, as we come to the end of this exploration, it's clear that crop rotation and intercropping are more than just traditional farming techniques. They are powerful strategies that combine centuries of knowledge with modern understanding of soil science and ecology. By varying what we plant and how we plant it, we not only improve soil fertility, control pests naturally, and increase yields, but we also create resilient farming systems that can adapt to changing climates, reduce environmental impact, and support biodiversity. These methods demonstrate that working with nature, rather than against it, is often the most efficient and sustainable path forward. For farmers, gardeners, and anyone interested in food production, the message is simple. Start small. But the impact doesn't stop at the individual farm. Widespread adoption of these methods can lead to healthier landscapes, cleaner water, reduced greenhouse gas emissions, and thriving ecosystems. Every rotation, every mixed planting, is a step toward a more sustainable and resilient food system, a system that can feed communities while protecting the very resources that make farming possible. So, whether you're a seasoned farmer looking to optimize your land, a beginner curious about growing your own food, or someone passionate about environmental stewardship,